Hey guys, my name is Kaavya, and welcome to 4th grade Math with Allstat. Today's topic is the operations in algebraic thinking standards. We will be covering how to use the 4 operations to solve problems, factors and multiples, and patterns. As always, our videos consist of 8 to 15 review questions, and each one is timestamped in the description box below. If you get the question right, feel free to skip to the next timestamp. If you want to review certain topics after the video, we have a links for further reference page in the description box below, along with all of our questions. Alright, let's get started with the first question. Okay, question number 1. If Derek has 3 times the amount of jelly beans his friend Mark has, and Mark has 50 jelly beans, how many jelly beans does Derek have? So we're going to give you a few seconds so that you can solve the problem, and if you need more time, feel free to pause the video here. Okay, so the answer to this question is Derek has 150 jelly beans. So this question is an example of a multiplicative comparison. A multiplicative comparison is when you compare 2 or more things using multiplication or division. So in this case, we know that Derek, who's represented by the letter D, has 3 times the number of jelly beans Mark has, who's represented by the letter M. And based on what the question said, we know that Mark has 50 jelly beans. Okay, and because Derek has 3 times how much Mark has, we know that Derek would have 3 times 50. And when you multiply 3 and 50 out, you get that Derek has 150 jelly beans. Okay, so moving on to the next question. So question number 2. If Alex has 5 times the amount of money his brother George has, and Alex has $30, how much money does George have? Okay, so pause the video here if you need more time to solve the question. Okay, so the answer to this question is that George has $6. So this question is another example of a multiplicative comparison, except this time it's flipped around. So we know that Alex has 5 times what George has. And Alex is represented by the letter A, and George is represented by the letter G. And based on what the question says, we also know that Alex has $30. So that means that $30 is 5 times what George has. So now to solve this equation, we would have to separate G from the rest of the equation. And to do that, you do the opposite of what is being done to G. So in this case, we're multiplying G by 5 to get 30. And the opposite of multiplication is division. So we divide this by 5 and this by 5. What that does is cancels the 5s out on this side. So now George has 30 divided by $5. And once you simplify that, you get that George has $6. Okay, so moving on to the next question. Question number 3. On Monday, Owen colored 5 pages from his new coloring book. Yesterday, Owen colored in 2 times the amount of pages he colored on Monday. And just today, he colored in another 2 pages. How many pages did Owen complete coloring in total? Okay, so pause the video here if you need more time to solve the question. So the answer to this question is Owen completed coloring 17 pages in his coloring book. So this question has multiple parts to it. We already know that from the question that on Monday, which is represented by the letter M, he colored in 5 pages. Yesterday, which is represented by the letter Y, he colored in 2 times the amount he colored on Monday, which is 5. 2 times 5. So yesterday, he colored in 10. And today, which is represented by the letter T, he colored in 2 pages. But now the question is asking how many pages he completed coloring in total. So to find that, you have to add the number of pages he colored on Monday, which is 5, plus the number he colored yesterday, which is 10, plus the number he colored today, which is 2. And that gets you 17. Okay, question number 4. Lexi has 6 boxes of marbles. In each box, there are the same number of marbles. Which of the following could be the total number of marbles Lexi has? A, 13, B, 16, C, 23, D, 18, or E, 26? Okay, so go ahead and pause the video here if you need more time. The answer to this question is D, 18. Okay, so if Lexi has 6 boxes and each one has the same number of marbles in them, that means the number of marbles, or M, must be divisible by 6. So we can use the process of elimination to solve this question since you're given multiple choices. So A, 13. So now we would check if 13 is divisible by 6, which it isn't, because you would get 2 with the remainder of 1. And this remainder, it means that it isn't divisible, so no. B, 16. So for 16, you would get 2 with the remainder of 4. So no. For C, 23, you would get 3 with the remainder of 5. So that's also no. For D, 18, you would actually get 3 with no remainder because 18 is divisible by 6. So yes. And for E, 26, you would get 4 with a remainder of 2. And since there's a remainder, it would be no. So since D is the only one that is divisible by 6, then you know the answer is D, 18. Okay, so moving on to the next question. Question number 5. Jackson's class is collecting box tops. His class's goal is to collect 240 of them. If he brings 16 box tops each day for 3 days, and the rest of his class brings 114 box tops in total during those 3 days, how many more box tops does his class need to collect before the deadline in order to reach their goal? Okay, so go ahead and pause the video if you need more time. So the answer to this question is they need to collect 78 more box tops. So to solve this problem, there are multiple steps actually. So we're going to start off with figuring out how many box tops Jackson brought during those 3 days. So we know he brought 16 box tops each day for 3 days. So that's 16 times 3. And when you multiply that out, you get that Jackson brought 48 box tops those 3 days. So now we have to find out the total number of box tops brought in during those 3 days. So we know that Jackson brought in 48, and the rest of his class brought in another 114. So when you add that together, you get 160. That is the number of box tops his whole class brought in. Now to find the number of box tops they need to bring in to reach their goal, you would subtract 162, which is what they've already brought in, from 240, which is their goal. And when you do that, you get 78. Okay, moving on to the next question. Question number 6. Izzy's grade is going on a field trip. If there are 124 students and 31 chaperones attending the field trip, and each vehicle holds 8 people, how many vehicles will they need in order for everyone to attend the field trip? Okay, so go ahead and pause the video here if you need more time to answer the question. So the answer to this question is 20 vehicles. So just like in the last question, there are multiple parts to this one. So we'll first start off by finding the total number of people attending. And the total number of people is the number of students, which is 124, plus the number of chaperones, which is 31. When you add 124 and 31, you get 155. So that's the total number of people attending. And now we know that each vehicle holds 8 people. So to find the number of vehicles you need, we're going to divide 155 by 8. When you do that, you will get 19, but you would get a remainder of 3 as well, because 155 is not divisible by 8. So what happens now is, in order for these 3 people to go, you need to add an extra vehicle for them, because the question asks how many vehicles we need in order for everybody to attend, and we can't leave these 3 behind. So you would add 19 plus 1, and then you get 20. So you need 20 vehicles in order for everyone to attend. Question number 7. What is 658,762,349 rounded to the nearest 10,000th place? Okay, so go ahead and pause the video here if you need more time. The answer to this question is 658,760,000. So this question focuses on something called rounding. Rounding is a type of estimation or rough calculation. When the digit in the number you're rounding to is followed by a 5, 6, 7, 8, or 9, you round up. If the digit you are rounding to is followed by a 0, 1, 2, 3, or 4, you round it down or keep it the same. So an example of rounding up is number 1. So rounding 48 to the nearest tens place. Let's look at which digit's in the tens place. In this case, it's a 4. And this 4 is followed by an 8. And since it's followed by an 8, you round it up. And when you round up, you look at the digit in the tens place and you move it up by 1. And 4 plus 1 is 5. And then all the digits after it become a 0. So it becomes 50. An example rounding down is number 2. So 43 rounded to the nearest tens place. So again, the digit in the tens place is a 4. And the digit after that is a 3. And since it's a 3, you round it down. So when you round down, you look at the digit you're rounding to, which is 4, and you keep it the same. But all the digits after it become a 0. So this becomes 40. It's rounding down because it's less than the number it was earlier. And an example of keeping it the same is number 3. So 40 rounded to the nearest tens place is 40 because the 4 is followed by 0, and it's kept the same because all the digits after the 1 in the tens place, which is 4, are left as 0. So in this question, they're asking you to round 658,762,349 to the nearest 10,000th place. So let's look at the digit in the 10,000th place. In this case, this digit is 6, which we put in red. So now let's look at the digit after that, which we're going to put purple. So the digit after that is a 2. And since this 2 is less than 5, and over here it says that if the digit you're rounding to is followed by any number between 0 and 4, you round it down or keep it the same. So this 2 is between 0 and 4, so you would round it down. So now this number becomes 658,760,000. And all the numbers after this 6 become a 0. All right, moving on to the next question. Question number 8. What are the factors of 35? Is it a prime or composite number? What about the factors of 23? Is that a prime or composite number? Okay, so pause the video here if you need more time to figure this one out. So these are the answers to this question. So the factors of 35 are 1, 5, 7, and 35 is a composite number. The factors of 23 are 1 and 23. 23 is a prime number. So this question focuses on prime and composite numbers. So a prime number is a number whose factors are only itself and 1. So for example, 7. 7's only factors are 7, which is itself, and 1. An example of a composite number is 10, because composite numbers have more factors than just 1 in itself. And 10's factors are 10, 1, 2, and 5. Oh, and a quick fact. All prime numbers are odd other than 2. So 2 is the only even number that is prime. Okay, so going back to the question. So the factors of 35 are 1, 5, 7, and 35. So, and since it has more factors than just 1 in itself, we know that 35 has to be composite. 23's factors are just 1 and 23. And since it has no other factors except a 1 and itself, it is a prime number. Question number 9. In the conference room, there are 18 chairs. How many ways can Richie organize the chairs if he wants at least 2 groups of chairs, at least 2 chairs in each group? Okay, pause the video here if you need more time for this question. Okay, so the answer to this question is 4 ways. So this question requires us to figure out the factor pairs of 18. So we're going to start off with doing that. So the first factor pair of 18 is 1 and 18. So when you multiply 1 and 18 together, you would get 18. The next factor pair is 2 and 9. When you multiply 2 and 9 together, you also get 18. The last factor pair is 3 and 6. When you multiply 3 and 6 together, you will also get 18. So now we're going to list these factor pairs out in ways Richie can organize the room. So for example, using this first factor pair, 1 and 18, we can say Richie can create one group of 18 chairs or 18 groups of 1 chair each. Using the next factor pair here, 2 and 9, we can say Richie can create 2 groups of 9 chairs or 9 groups of 2 chairs each. And using the last factor pair here, 3 and 6, we can say Richie can create 3 groups of 6 chairs or 6 groups of 3 chairs each. Now, going back to the question, it says that Richie wants at least 2 groups of chairs and at least 2 chairs in each group. So now we're going to go to the groups column. We're going to see if any of the numbers are less than 2. And in this first combination, this number is less than 2, which means it will only have, and since it's 1, that means there's going to be only one group of 18 chairs. But that doesn't fit what Richie wants, so we're going to cross that one out. And then the rest of the numbers are at least 2, so that's fine. Now we're going to look at the next thing Richie wants, which is he wants at least 2 chairs in each group. So now we're going to go through the chairs column, and we're going to see if any of the numbers there are less than 2. We can see in this second combination, the number of chairs is only 1, so it's 18 groups of 1 chair each, which doesn't fit what Richie wants either, so we're going to cross that one out too. Now, we are left with these 4 ways. Okay, moving on to the next question. Question number 10. April's jar has 17 marbles in it. Every day she starts putting in another 3 marbles. How many marbles will April have in 10 days? Okay, so go ahead and pause the video here if you need more time for this question. So the answer to this question is 47 marbles. This question is an example of a pattern or a sequence, which repeats the same process over and over again. So the first step to solving a pattern is figuring out the rule of it. So in this case, you'll be figuring out the rule of the pattern of how April is adding marbles to her jar. So J is for jar. And we know that her jar already has 17 marbles in it before she starts adding marbles. And then every day, she starts adding 3 marbles. So 3 times the number day it is. So for example, on the 5th day of adding marbles, so 3 times 5 is 15, there will be 15 new marbles that weren't there on the original day. So over here in this chart, we're going to fill this out. So we're going to start off with the original day. So you have 17 times plus 3 times 0. And you're just going to get 17 for this because 3 times 0 is 0 plus 17. So this is the original number of marbles April had before adding marbles to her jar. On to the second one. So this is the first day of adding marbles. So you have 17 plus 3 times 1. And for this, you'll get 20 because 17 plus 3 is 20. So, and this just works for the rest of the chart. So this is what the chart looks like when it's all filled out. So we're going to do this last one over here. So we have 17 plus 3 times 10. So this is the 10th day of adding marbles. So 3 times 10 is 30 plus 17 is 47. So this is the number of marbles April will have after adding 3 marbles for 10 days each day. Okay, so one thing you may notice is that there is a pattern to the number of marbles. So, for example, 17 plus 3 is 20. So each one is 3 more than the one before. So 23 is 20 plus 3. And going all the way down here, 47 is 44 plus 3, which makes sense because every day April is adding 3 marbles. Okay, so another way to solve this question without creating this whole chart is just plug in the number of day into this D. So for example, we're trying to figure out how many marbles April will have in 10 days. So we're just going to do 17 plus 3 times 10 for D. And that just equals 17 plus 30, which gets you the same thing. So that is 47 marbles. Question number 11. Arizona and Cali both have a dog sitting business. Arizona charges $12 per dog and $4 per hour, while Cali charges $8 per dog with an additional fee of $5 per hour. If both of them dog sit for one dog for 5 hours, who will earn more and by how much? Okay, so pause the video here if you need more time with this question. The answer to this question is Cali will earn $1 more. We're going to solve this question using equations. Okay, we're going to start off with writing Arizona's equation. So A is for Arizona, and she earns $12 per dog, so that's 12 times D, D is for dog, plus $4 per hour, so 4 times H, and H is for hour. So it says that both of them dogs sit one dog for 5 hours, so we're going to plug 1 in for D and 5 in for H. So we're going to write that down on the side. So in this case, D equals 1 and H equals 5. So you would do 12 times 1 plus 4 times 5. When you multiply 12 and 1, you'll get 12. And then you add 4 times 5, and 4 times 5 is 20. When you add 12 and 20, you get 32. Okay, now we're going to move on to Cali. So Cali, she charges $8 per dog, so that's 8 times D plus $5 per hour, so 5 times H. And again, we're going to plug in 1 for D, so it's 8 times 1. We're going to plug in 5 for H, so it's 5 times 5. When you multiply that out, you'll get 8 times 1 is 8, plus 5 times 5, which is 25, and 8 plus 25 is 33. So you can already see that Cali earns more money because 33 is greater than 32, but now you have to find how much more money that is. So to find that, you're just going to subtract 32 from 33. When you do that, you'll get 1. So Cali earns $1 more. I hope that this video was a good review of these standards. And as I mentioned in the beginning of the video, feel free to check out the links for further reference page down in the description box below. If you have any more questions, feel free to let us know in the comments down below. If this video was helpful, please like, share, and subscribe. Thank you, and I'll see you again in the next video.